Hello everyone, in today's video we have this interesting problem. We have 27 to the power x plus 3 to the power x is equal to 350 and we have to find the value of x. But before we begin, feel free to pause the video and try this first. Done? Cool. Now let's get started. First, we're going to make the basis on the left hand side of the equation the same. So what it means is that we're going to change this 27 to 3. And to do that, 27 could be written as 3 to the third power, then all to the power x, plus 3 to the power x is equal to 350. Now from indices, a to the power m or to the power n is the same as a to the power m times n, and it is also the same as a to the power n or to the power m. So what it means is that we can write this whole thing in this form, right? So we're going to have this to be 3 to the power x or to the third power plus 3 to the power x, and this is equal to 350. And from here, we're going to let 3 to the power x equal to y. So wherever we see 3 to the power x in this equation, we're going to put y. So we're going to have y to the third power plus y is equal to 350. And this is where the challenges in the problem come from. Let's analyze this equation. If we factor y out, we're going to have y times y to the second power plus 1, and this is equal to 350. This y squared over here is a perfect squared. Then everything in the parentheses is perfect squared plus 1. So what it means is that we can write two factors for this 350 in such a way that one of them is perfect squared plus 1. Now let's pay attention to this side. If we assume that y is equal to 7, then it means that we're going to have, from here we're going to have 49 plus 1, of which this 49 is perfect squared plus 1. So it means that the factors are 7 and then 50. This 50 is made up of perfect squared plus 1, which is 49 plus 1. So from this idea, we can say that y is equal to 7. But the equation is polynomial. We have 3 to the third power. So it means that we need to get 3 solutions for y. From this idea, we only got one solution. But this is going to help us get the other solution. So now that we know that y is equal to 7 is one of the solutions, we can write this equation in the form y to the third power plus y is equal to 7 plus 343, because this 350 is the same as 7 plus 343. Now let's equate everything to 0. We're going to have y to the third power plus y minus 7 minus 343 is equal to 0. And this is also the same as y to the third power plus y minus 7 minus this 343 is the same as 7 to the third power, and this is equal to 0. Now let's group the terms with the third powers and then group the terms with the first powers. So we're going to have y to the third power minus 7 to the third power as one of the groups, then plus y minus 7, and this is equal to 0. And from here we can apply one of the identities, which states that a to the third power minus b to the third power is equal to a minus b times a squared plus ab plus b squared. So what it means is that y to the third power minus 7 to the third power is equal to y minus 7 times y squared plus 7y plus 49. So in place of y cubed minus 7 cubed, we're going to put this whole thing. So the equation now becomes y minus 7 times y squared plus 7y plus 49, then plus y minus 7, and this is equal to 0. And from here we can see we have y minus 7 here. So we can factor it. We have y minus 7 times. From this whole thing, we are left with this. So we're going to have y to the second power plus 7y plus 49. Then from this part, we are left with 1. So we're going to have plus 1 here, and this is equal to 0. And we can simplify this further as y minus 7 times y squared plus 7y plus 50 is equal to 0. And at this point, we can say that y minus 7 is equal to 0, or y to the second power plus 7y plus 50 is equal to 0. And from this equation, straight away, we can see that y is equal to 7. Or from this equation, what we're going to do is to find the discriminant, which is d is equal to b squared minus 4ac. So if you compare this equation to the general quadratic equation, we can see that b is equal to 7. So we're going to have 7 squared, which is 49, minus 4a, a is 1. So we're going to have 1 times c, c is 50. So we're going to have 50. And this is equal to 49 minus 4 times 1 is 4 times 50. We're going to have 200. So it means that we have d to be negative 151. And we see that d is less than 0. So it means that this equation has no real roots. So the final answer to this problem is y is equal to 7. But remember, initially we let 3 to the power x equal to y. So when y is equal to 7, we're going to have 3 to the power x is equal to 7. Now let's take log in base 3 on the both sides of the equation. So we're going to have log in base 3 of 3 to the power x is equal to log in base 3 of 7. And now applying the rules in logarithm, the powers now becomes the coefficient. So we're going to have x log in base 3 of 3 is equal to log in base 3 of 7. Now log in base 3 of 3 is equal to 1. 1 times x is x, so we're going to have x is equal to log in base 3 of 7. And this is equal to 1.771243749116. So this is the final answer to the problem. So guys, if you found this video useful, please smash the like button and also let me know your thoughts about this problem in the comment section. Thanks a lot for watching. See you again on the next video. Have a good day. Bye.